Welcome to the channel, Optical Mechanic here. This video is the next instalment of the Apprentice steam engine project, and recently I uploaded a video where I was machining the flywheel and the crankshaft, and in this video I'll be machining these three parts here. As you can see, I've already machined them, so following will be the footage of those with a commentary on what I'm doing at what stage. But the three parts are, this is a piston. So the piston is 20mm long, 16mm diameter, and it's got an M6 thread down the middle. And this part here is the connecting rod. It's not very big. This is 6mm diameter that I've turned down from 10mm stainless bar, the piston stainless as well, and I've cut an M6 thread on the end, and this just screws into the back of the piston like so. So all that remains on this job here now is on the con rod. I just need to mill a couple of flats on, and then it'll be right to drawing. And then I also machined this top cap, which presses into the cylinder head. So this has got a spigot machined on the back. I've put a little lead chamfer on there, and to clear the tool radius in there, when I machine the bore in the cylinder, I'll make sure that I've got a good chamfer there. The top is conical, and I experimented to see how good a finish I could get with my chamfering tool. So I'm not altogether satisfied with it. So I was being a little bit lazy. I was trying to avoid having to put the compound slide onto the machine, and I'll probably recut this surface here when I get a chance. But it's not too bad. I wanted to see what kind of finish I could get with the chamfering tool, and it's a 45-degree chamfering tool which I rotated slightly to get close to the cone angle on here, and I just took it in cuts, 0.5 millimeter step over distance each time, and it didn't come out too badly, but I know it can be better, and I'll recut that with the compound slide. And then the other thing just to say quickly in this video is, for coolant I've been using this stuff here. So it's water soluble oil. This is made by Morris Lubricants, and it's Supercut 1000. I'm not saying it's the only coolant that should be used for this application, but it's the one I'm using, and it seems to be doing a good job. And the way I'm applying that at the moment is with one of these little squeeze bottles which I've bought from Amazon. I've bought 3 of them, and I've mixed it up at 5% concentration. So it seems to be doing the job. It's inhibiting corrosion on the machine nicely, and is keeping the work and the tool nice and cool, so that's good. So I'll cut now, and I'll go into the footage of me machining the various parts. So we're putting some 316 stainless steel bar stock in the chuck now, and I start off by cleaning up the end of it. I could have just cut that off with a hacksaw, but I was being a bit lazy, so I'm just machining this off. This is the remnant of some trial cuts that I was doing with the rear tool post a few weeks ago. I'll get rid of that extra bit there, and then I'll face off, and then we'll be ready to start machining the spigot feature on the back side of the top cap. Reversing the tumbler gears there because I had the feed rate engaged for facing off, so I have to stop the spindle and change the tumbler gears in order to change the direction of the feed. This material machines quite nicely when you get the right feeds, and with these carbide inserts I'm finding that I'm getting quite a nice surface finish with 316. Stainless it's a marine grade stainless steel, so it's very resilient against corrosion. So for a little model engine that's going to be sitting possibly in damp conditions occasionally at some point in the future, hopefully it will retain its shine and corrosion resistance. So here I'm just cleaning up the major diameter on the top cap. There's not much left behind after the cone feature's machined on, but at least I know that it's machined nicely, and just give that little clean up with some fine emery there now. And all that remains now is to part off, and then that'll be the first operation complete on the top cap. The only downside to not having a coolant system on the lathe is that you don't have your hands free, so you've always got one hand at the ready to disengage the feed, and then the other one is keeping the work cool. So I'll be glad when I've got round to fitting the coolant system onto the machine. So here onto the second op now. So what I've done here is I've reversed the parts in the chuck. I've got some aluminium, it's a bit of a drinks can just to protect that precision spigot diameter from getting marked up by the chuck jaws. I'm trying something a bit different here. I'm facing off with the chamfering tool, which isn't in its normal orientation, so I've angled the multi-fix tool post slightly so that I can get this approach angle, and I'm just using the tip of the chamfering tool to face off. It doesn't produce a fantastic finish. In hindsight, I probably should have put a new insert in here, but anyway. So I faced off, and then I indexed over by 0.5 millimeter, and then drove in to my X position, and then on the second cut here, which I'm about to start the third cut, I've indexed 0.5 millimeter each time in Z, and I've just driven into the X position. And then I just clean up the last bit so that it looks right, and then the whole thing just gets a bit of a clean up with emery just to tart it up a bit. Just measuring the diameter of the truncation. So now we're on to the second part, which is the piston. So I've got the bar stock back in the chuck, and I'll start off by facing off. This piston, I want it to have a nice surface finish, and to be good for diameter as well, because this needs to be a really good fit into the bore of the cylinder. So I'm machining this to the drawing tolerances, and what I'll do is I'll fettle this on assembly just to make sure I've got the right kind of fit inside the cylinder. I did toy with the idea of making a piston out of nylon 66 or Delrin, and I might still do that just because for its wear resistance properties and low friction, which would probably provide less resistance within the cylinder, just to make the engine run a bit more efficiently. Slightly defocused here because I didn't have the camera set up that well, and my focus is normally the machining and not the filming. So anyway, we'll get better over time. I've changed over to the DCMT here because I was afraid of getting some swarf trapped between the tool and the work, because there's not much of a clearance angle on the CCMT. So with the DCMT, as you can see, there's a massive clearance angle, and so I tend to use this tool for finishing, and then so this is tool number 2, and tool number 1 is the CCMT, which is the tool that I did the roughing with a minute ago. So I'm just finishing this off to size now. So the piston diameter is within spec, and now I'm just putting the drill chuck holder onto the multi-fix tool post, setting up for just centre drilling the hole there. Now we'll come in with an M6 tapping drill in a second. I'm drilling this hole to a depth of approximately 10 millimeters, and I'm using the carriage feed to drive the drill through. I'm drilling at a feed rate of about 2 thou per rev. And I just break the swarf every few millimeters, so I don't get a massive ribbon of swarf. It's a bit easier to handle and a bit safer. Just going in with a countersink now just to chamfer that hole, and I've put quite a decent sized chamfer on, so that even after I've tapped the threads there'll still be a chamfer there. It just saves coming back in again afterwards to deburr the thread, and there's always a risk of damaging the thread anyway when you chamfer after cutting a thread, so I prefer to put an oversized chamfer on first and then cut the thread. So here I'm just starting the M6 taper tap. I haven't got a mega tight grip on that tap in the drill chuck, because I'm always a little bit paranoid about power tapping on the lathe, just in case it busts the tap off in the work. And then once I've got it square and a few threads started, then I'll tap it by hand after that. Just giving that a little polish just so that there's no bruising or any burr there, which might cause a problem with the fitting of the piston into the bore upon assembly. And just checking that the Z0 is correct for tool number 6, which is the parting tool. And as you can see, I've got the coolant there, and the parts parted off nicely. So op 2 for the piston now. So again, similar story, reversed the job in the chuck, protected it with some aluminium foil from a drinks can, and I'm just going to come in now face off with the DCMT tool, put a chamfer on, and then just clean it up with some fine emery again. It's not just for aesthetics coming in with the emery. It does do a good job of just removing any bruising that can occur after putting the chamfer on. You do have to be very careful that you don't wear any sleeves or anything like that could get wrapped up around the chuck. So I'm an experienced machinist, so I'm quite comfortable coming in with emery just to clean the work up. So here we are now. This is part number 3. This is the connecting rod, and I've just put the work up in the chuck, just figuring out how long I want to have it sticking out. So I've just marked the work off there. So I've just brought the material back into the chuck so that I can face off and centre drill. and then once that's done, I'll pull the material back out of the chuck and support it with a centre, a live centre, because we're going to machine about 50 millimetres in length off the end of this bar. So I'll be machining it down to 6 millimetres because there'll be an M6 thread on the end. So I wouldn't want to machine that. It's 10 mil bar this, so there's no way I'd want to machine that like that. So so that's why I'm coming in with the centre now. So that's supported. So I'll just whiz this material off now. So I've been quite delicate with the work there. I didn't want to take heavy cuts off it because it's quite a small diameter bar, and I didn't want to deflect the work and then end up with a ropey finish. Just putting a chamfer on with the file just so I have a little lead for the M6 die to come in and cut the thread in a second. And here's the shop made die holder, just held in the drill chuck there, and just cutting the thread on to the end of the connecting rod. So I'll just come in with the parting tool, and instead of parting straight through, I swap the tools around so I can come in with the chamfering tool and just chamfer that edge there. So if you made it this far, thanks for sticking around, thanks for watching the video, and what we've got laid out here on the bench is the parts that are made so far. So we've got the flywheel, the crankshaft, the bearing, the main bearing journal in its housing, and the main shaft, the top cap, and the piston and conrod. So hopefully in the next video we'll make a start on the milling operations, and then we'll start hopefully putting some of these things together. Thanks for watching, and I'll see you soon. Bye for now.